morning, students. Myself, Professor from UNJ Institute of Engineering and Technology. Today, we are going to discuss the subject probability and statistics. So, let's start. Today's topic of the discussion is two-dimensional discrete random variables and example related. So, let's start. In one-dimensional random variable, the outcome of any experiment had only one characteristic. In many situations, the outcome of a random experiment depends on two or more characteristics. Example, both voltage and current are measured in a certain experiment. Let x and y be two random variables defined on the sample space S. Then the function xy that assign a point in R square is called a two-dimensional random variable. A two-dimensional random variable is said to be discrete if it takes at most a countable number of points in R square. When xy is two-dimensional discrete random variable, the possible values of xy may be represented as xi, yi, where I running from 1 to m and j running from 1 to m. Joint probability mass function. If xy is a two-dimensional discrete random variable, then the joint discrete function of x and y, also called the joint probability mass function of xy, denoted by small p in the suffix that is xy, so small p of xy is defined by type equation is defined by pxy xiyi equal to px capital X is equal to small xi, y is equal to small yj for all values xi, yi of x and y, and p of xy of xi and yi is equal to 0 otherwise. So the following conditions should be satisfied for a function to be a probability mass function, and these two conditions are most important conditions. The first one is p of xy for xi and yi greater than or equal to 0 for all I and j, and summation running from j1 to n and running from I1 to m pxy where xi by j is equal to 1. So this is about the cumulative distribution function. If xy is said to be two-dimensional discrete random variable, then f of xy of x and y is equal to probability of capital X less than or equal to x and capital Y less than or equal to y is called cumulative distribution function CDF of x and y, and it is defined by here capital F of xy is equal to xy is equal to summation j running from 1 to n, I running from 1 to m, where p of xy is equal to xi yj equal to summation of pij. Now, the properties of CDF. These are the properties of CDF. CDF is cumulative distribution function, right? So, number one, f of minus infinity to y equal to 0, or we can say that f of x to infinity and f of infinity to infinity is equal to 1. This is the first property, students. For the second property, here the two-dimensional discrete random variable, it is here p, is where a is less than x less than b and capital Y is less than or equal to small y. What does it mean? It is equal to f of by minus f of ay. For third one, if probability of capital X less than or equal to x and c less than capital Y less than d, it means it is f of xb minus f of xc. Fourth property, p of a less than x less than b and c less than capital Y less than d, it means f of bd minus f of ad minus f of bc plus f of ac. The last property, students, for a discrete random variable, f of xy of x and y will have a step discontinuities. Derivative at such discontinuities are not defined at points of continuity. So del square f upon del x del y is equal to f of xy. And the last here, conditional probability function, and that is let x and y be a two-dimensional discrete random variable, then the conditional discrete density function or conditional probability mass function of x given capital Y is equal to small y denoted by rho xy. Here the bracket x by y is defined as, this is small p x by y is equal to small p, capital X is equal to small x, oblique capital Y is equal to small y is equal to p of capital X is equal to small x and capital Y is equal to small y upon p of capital Y upon small y, provided that your denominator must not equal to 0. It is same for the conditional probability mass function of y, where given capital X is equal to small x and it is denoted by p of y by x, right? It is same as the upper. A necessary and sufficient condition for the discrete random variable x and y to be independent is this. Got it? And the next one is marginal probability function, and that is summation. Let x and y be a two-dimensional discrete random variable which takes up a countable number of values xi and yj. Then the probability distribution of x is given by p of x for all xi is equal to capital P x is equal to xi, right? What does it mean? Here x is equal to x1 and y is equal to y1. Similarly, x is equal to xi and y is equal to y2 up to x is equal to xi and y is equal to ym, right? So we may write it pi1, pi2 up to PIM, right? So it is equal to summation j running from 1 to m Pij, right? So, and it is known as marginal probability mass function or discrete marginal density function of x. It is known as discrete marginal density function of x. Okay. Similarly, we may write the discrete marginal probability function of y. It is like here p y, it is yj. Here probability of capital Y is equal to all yj, right? So this summation I running from 1 to n p I j, right? So it is known as marginal probability function. Students, let's move for some example for the better understanding, and that is from the following table for bivariate distribution of x and y, find probability of x less than or equal to 1, probability of y less than or equal to 3, probability of x less than or equal to 1 and y less than or equal to 3. Then fourth one, fifth one, and sixth one, right? So let's start the solution here. We have to find the solution with the help of this bracket. Students, in this bracket, this one is y and this one is x. Okay. So when I start my solution, first First, I start with marginal distribution. Okay. And for the marginal distribution, as per the formula, this is the symbol of the marginal distribution, that is Px, right? And here Py. So the sum of all these values are what? It is 8 upon 32. See here, 1 by 32, 2 by 32, 2 by 32, and 3 by 32. That is 8 by 32. Same way, 1 by 16, 1 by 16, and 4 times 1 by 8, right? So if I take LCM here, then that is 2, 2, 2, 2. 4 times 2, so 8 plus 2. So that is 10. 10 by 16, right? And same way in the denominator, it is 8 by 64. Similarly, from the column wise, if I take the summation, it is 3 by 32. Again 3 by 32, right? 11 by 64. 13 by 64. 6 by 32. And 16 by 64. So, summation of Px is equal to 1 and summation of Py, that is also 1. Got it, everyone? Okay, if I take the summation of all these value, it is 1. The summation of this value, it is also 1. So, let's start to find the probability accordingly. So, my first question is probability of x less than or equal to 1. What does it mean? I have to find the probability of x equal to 0 plus probability of x equal to 1. And what is that? Probability of x 0. See here. Probability of x. So this one is x, right? So probability of x is 0. That is what? 8 by 32, right? And probability of x equal to 1. That is 10 by 60, right? So here 8 by 32 plus 10 by 60. So after simplification, it is 7 by 8. Second one, this is about this first. Now the second, probability of capital Y less than or equal to 3. It means probability of capital Y equal to 1 plus Y equal to 2 and plus Y equal to 3. Now what are the value of 1, 2 and 3? See here, for this Y, that is 3 by 32. For Y equal to 2, it is 3 by 32. And for Y equal to 3, it is 11 by 64. So, from that table, 3 by 32 plus 3 by 32 plus 11 by 64. So after simplification, it is 23. If I take LCM here, here 6 plus 6, right? So 12 plus 11. So that is 23 by 64. For the third one, here probability of x less than or equal to 1 and y also less than or equal to 3. So my first value, probability of x equal to 0 and y equal to 1. Then next one is probability of x equal to 1, y equal to 1. X0, y1, x0. If I keep x constant, x is 0, then y2. And probability of x0, y. Got it? Similarly, plus probability of x1, y1, probability of x1, y2, and x1, y3. Okay, so we have total 6 values here. And if I keep x0, y1, that is what? See here, x0, this one is x0 and y1 is 0. Then x0, y2, that is also 0. X0, y3 is 1 by 32. Got it, everyone? Similarly, x1, y1 is 1 by 16, x1, y2, 1 by 16, x1, y3, 1 by 8. So, it is 0 plus 0 plus 1 by 32 plus 1 by 16 plus 1 by 16 plus 1 by 8, and it is equal to 9 by 32. Okay, this one is the third one. What about the fourth one? Fourth one is probability of x less than or equal to 1 upon y less than or equal to 3. It means here probability of x less than or equal to 1 and y less than or equal to 3. Okay, and upon probability of y less than or equal to 3. So here probability of x less than or equal to 1 and y less than or equal to 3. See from the third answer, that is 9 by 32. So here 9 by 32 upon 23 by 64. So after simplification, it will become 18 upon 23. The fifth condition is, students, probability of capital Y less than or equal to 3 by x less than or equal to 1. It means probability of x that is greater than or equal to 1 and y which is less than or equal to 3 whole divided by probability of x less than or equal to 1. So here probability of this one is less, not greater. The probability of x less than or equal to 1 and y less than or equal to 3. From the upper answer, it is 9 by 23 and upon it is 7 by 8. So after simplification, it will become 9 by 28. Okay, got it, everyone? And the last one, sixth one, that is probability of x plus y, which is less than or equal to 4. What does it mean? X equal to 0, y equal to 1. First, x0, y2, because the summation of 0 plus 1 is 1, which is less than or equal to 4. 0 plus 2, it is again less than or equal to 4. Then 0, x0, y3, which is also less than or equal to 4. x0, y4. Got it? Now, next one is x1, y1 plus x1, y2. 1 plus 2 is just 3. x1, y3. 1 plus 3 is 4. Okay, so don't move ahead now. Now we'll take x equal to 2. So probability of x2, y1 and x2, y2. 2 plus 2, 4. Next one. Value of x is just 1 and 2. See here, right? So we cannot take more than 0, 1 and 2, right? So here all possibility for x and y are here. Okay. So if I substitute the values here, 0 plus 1 by 32 plus 2 by 32 plus 1 by 16 plus 1 by 16 plus 1 by 8 plus 1 by 32 plus 1 by 32. All these value you will get from this table. This is marginal distribution table. Got it? So with the help of the value of this table, after summation, you will get final answer, that is 13 by 32. Got it, everyone? Okay. Let's move for the one more question for the better understanding. The joint distribution of x and y is given by f of xy is equal to x plus y upon 21, where x is 1, 2, 3 and y is equal to 1, 2. Find the marginal distribution. Okay, so here this is in this table, this one is x is 1, 2, 3 and this one is y. Okay, so the small p y of y, and that is 9 by 21 and here 12 by 21, right? And this one is small p x of x, and that is again this one is just 3 plus 2, so 5 by 21. Got it? And this one is 7 by 21. This one is 9 by 21, right? And if you will find summation of px, that is 1, 12 plus 9, 21. See, 7 plus 5, 12 plus 9, 21 by 21. And summation of py, that is also 1. Okay, so marginal distribution of x, that is p of capital X is equal to 1. And here, p of capital X 1, y 1, and p of capital X1, y2. That is 2 by 21 plus 3 by 21. So final answer is 5 by 21. Got it? Similarly, probability of x equal to 2. So p of x equal to 2, y equal to 1, and again px2, y2. So by substituting the value, this, and that is 3 by 21 plus 5 by 21. So my answer is 7 by 21, and this is the answer of p of x equal to 2. Next, p of x equal to 3, and that is p of x equal to 3, y equal to 1, and p of x equal to 3, y equal to 2. So my answer is, it is 4 by 21 plus 5 by 21. So final answer is 9 by 21. And marginal distribution of y, that is p of y equal to 1. And here p of x1, y1, second p of x2, y1, and third p of x3, y1. That is 2 by 21 plus 3 by 21 plus 4 by 21. So answer is 9 by 21. The last marginal distribution of y equal to 2, and that is probability of x1, y2, x2. y2. And last one, x3, y3. Values are, it is 3 by 21. This one is 4 by 21, 5 by 21. And final answer is 12 by 21. So students, these are the marginal distribution from the given data. Got it? So I think now you understand how we find the marginal distribution from the given data. Okay. Feel free to contact me for any query. Till that, enjoy the study. Thank you, students.